I welcome all of you to the last day of our program, Optimizing Next Gen Computing for Smart System Development. So, today's first session is going to be delivered by Dr. Sandeep Singh Sengar, sir. So, he is going to discuss about motion segmentation based surveillance video compression using adaptive particle swarm optimization. So, it's my privilege to introduce Dr. Sandeep participants. So Dr. Sandeep Singh Sengar is a senior lecturer and the head of computer vision and artificial intelligence at Cardiff Metropolitan University, United Kingdom. He also serves as the cluster leader for computer vision, image processing, and represents the British Computer Society. Prior to his current role, Dr. Sengar was a postdoctoral research fellow in the machine learning section of the computer science department at the University of Copenhagen, Denmark, the country's top ranked university. In 2022, he was a visiting researcher at University College Dublin, the second ranked university in Ireland. Dr. Sengar earned his PhD in computer vision from Indian Institute of Technology, Dhanbad, and his MTech degree from Motilal Nehru National Institute of Technology, Allahabad, India. He is a fellow of the UK Higher Education Academy and a senior member of IEEE. His research focuses on machine deep learning, computer vision, and image or video processing. He has an extensive publication record in leading international journals and conferences. He has published in top tier venues such as MIE, NCAA, CPP, EFMI, IGCI, BMBC, and JBCIR. He is a member of the editorial boards for Signal, Image, and Video Processing, International Journal of Imaging Systems and Technology. He also serves on the board of studies at University in Mumbai, India, and reviews research grant proposals for UK, Singapore, and Cardiff Metropolitan University. Additionally, he is a PhD examiner for several prestigious institutions, including the IITs and the NITs in India. He has played key roles in international conferences, such as serving as an organizing chair and distinguished guest. He has also delivered expert talks worldwide at renowned institutions, including Trinity College Dublin, University College Dublin, Denmark Technical University, various Indian Institute of Technology, Cardiff University, and many others. So, with this short bio, I welcome Dr. Sandeep Sengar to our program, and I request him to start his session. Over to you, sir.
Thank you, madam, for this introduction. But I think the title of the talk was changed.
Okay,
So,
sir. Okay.
yeah, so it is a different one, like whatever you told. So, today I'm going to discuss about the understanding the role of AI in modern research. So, first of all, good afternoon, everyone. It's a morning here, so good morning, everyone. And today I'm going to discuss about how people are doing modern research using AI and how they can incorporate AI, artificial intelligence, in modern research. So we will understand the role of AI in modern research in this talk. I will try to complete that in 90 minutes, whatever time is allocated to me. If I will feel like I can't complete, then I will try to skip some of the part. So hope you enjoy this presentation. Hope you will enjoy this talk, and I would like to make this talk interactive, right? So if I'm asking question, then you please reply, and I would prefer don't type in the chat box, just unmute and speak. That would be great, because I can't see the chat box while sharing the screen. And if you have any question, please feel free to stop me in between and ask that, right? So because we are going to discuss about research, and like almost all of us, we are involved in research in different dimensions, right? So this is the overview of talk. Here, I will start with the introduction to research phases. Means what are the common phases that we will discuss. Then what is artificial intelligence, then significance of AI in multidisciplinary research, overview of AI subfields relevant to researchers, AI tools for ideation and drafting this. answers using AI tools, right? Then conclusion. So let's start with the phases in the research process. What are the phases in the research process? The first phase is problem identification. Whenever like any of the researcher, PhD student or master student, they start their research, then the first point is identification of the problem. They need to identify the problem, in which domain they need to work. For example, they are computer science researcher, then in a computer science, which field? So many fields are there. Like computer science is very broad, so they need to identify a particular specific area, a specific domain. So they need to identify the problem. So this is one of the important phase. We'll see about this in detail also. Then second phase is literature review. So once they identify the problem, then they need to search more about that problem. So search more about the problem means they read research papers. So depends on the application, but mostly if you want to do effective research, then we should read latest research papers like from last 5 years, 6 years. Okay, and so on the basis of that knowledge, then we need to we need to incorporate the knowledge of previous literature to our for our novel research for novelty. Then formulation of hypothesis means we need to formulate the hypothesis to prove our research will go in a better way and all those things, right? Then research design and methodology development. This is the core component of research, means whatever we did earlier in previous three phases, and now how we will incorporate and how our model and method will take place. So that is research design and methodology in this part. Then data collection and analysis. So different types of data collection strategies are there. So we'll discuss about all these points. So I'm going directly to the main point, problem identification. So problem identification means to define and clearly state the issue or gap in knowledge that the research aims to address. So here, before gap, first of all, we need to think in a real world. For example, we are working in computer vision, then we need to see in our surrounding environment in real world where we can apply computer vision. People are applying computer vision in different domains, but where is the problem, where is the gap, so we can fill that gap with the help of our research. So we need to clearly state the issue, we need to clearly see the issue and gap, and that gap we can fill. For example, I can give you one example here related to computer vision. For example, in the morning, there's a traffic signal, so red light is there, right, in most of the places. So even the person is going to be late for their office, then then also they have to stop on the red light, right? And they can't cross the red light, and they can't cross the traffic and all those things. So can you propose something? Can you develop something by which people can get rid of all these things, people can save the time. So you can apply computer vision, or you can think some other way, in another way with the help of AI and all those things. So in this way, you need to identify the problem. So here the problem is people are going to be late for their office due to traffic light or due to the traffic and all those things. So how can you propose how, so this is the problem identification, means you identify the issue in the system. So for your research, this is one of the good topic. In the same way, in your application area, you can think about the problem. In real world, you need to think about the problem, clearly state the problem. Now, key steps, for example, how you will identify the problem: observing phenomena or trend. For example, rising level of urban air pollution, right? In many of the cities, there's a huge air pollution. So how we can reduce that thing, right? And then identifying knowledge gaps, when what is not what is not yet known, right? So what is not yet known and what has been insufficiently studied. So we can identify the knowledge gap while doing the problem identification. Then assessing feasibility, means is the problem reachable within the available time, resource, and scope. So we need to assess the feasibility, means for example, we need to complete our PhD in 3 years or 4 years, whether can we achieve this task within 3 years or 4 years, or it might take more than that time. Or for example, you need to do your master's thesis in 6 months or 1 year. Then can we complete that problem in 1 month or 6 months? These all things we need to take care while selecting the problem. Then framing research questions means, can AI model predict urban air quality based on traffic and weather data? This is another example, like how means can AI will be can we use AI for predicting the urban air quality based on traffic and weather data? So we need to frame the research question, right? So these are the these are the we can see the points we need to consider while doing problem identification. Now, after problem identification, we have a literature review. And so, what is the purpose of literature review? The main purpose of literature review is to get to gain existing knowledge. Means, for example, we selected any topic, any problem, then we like how people are working on that problem, whether the problem is already solved or people are still working or they did not start here. So we need to get knowledge from the literature, and for that purpose, I will say, read latest research papers from last 5 years, 6 years, like that. And it depends on your application area. In few applications, you need to read like few old research papers also. So using this research literature, using this all these literature and all those things, what you need to do, you need to find the gap. You need to find the gap, like what is already existing and what we are proposing, right? So that gap should be solid, right? So this is the thing, this is the purpose of literature review. And key steps of literature review is, like, first of all, like, to systematically search for scholarly databases like Scopus, Web of Science, PubMed, Google Scholar, right? So you need to read research papers from these websites. Then you can use AI tools also for your literature review, like illicit corrected papers, research service. So these are the latest research tools you can use for faster and more structured literature discovery purpose, right? So if you want, you can note it down these tools. These are the very good. And organizing literature by themes, theory, and methodology. So based on that, you can organize. So this is one of the important points. So I would suggest to PhD students or researchers, if they are going to start their research in any of the field and they are doing literature review, then I will suggest them to write a one systematic literature review paper, because they read lots of papers. And at the end, when we complete our PhD or when we complete our research, then those knowledge, like the knowledge that we gained while doing the literature review, that knowledge is not, that knowledge is not useful after that time, right? So we forget and have other things. So better to utilize that knowledge. And so for utilization purpose, I would suggest to write one systematic review paper in the beginning of your PhD, on the basis of the theme, on that, like, you are doing your research, right? So I'm like to give you one example of one of my paper that we completed in 2024, generative artificial intelligence is systematic review and application. So this paper is quite popular, and I'm the lead author in this paper. And we got around 242 citations within 1 year of its publication. And now the nowadays, like, citation is more than 300 around, right? So I would like to show you this paper, like how to write systematic review paper and all those things. So quickly I will go through, so you can get an idea, the like how we can write the uh, effective paper. So it can be a very popular in it can be a very popular in the society and all those things, right? So first of all, a very important point is, uh, first of all, the important point is, if we write any of the paper, especially review paper, then your titles should be very catchy, right? So generative artificial intelligence, right now it's very popular, right? So titles should be very catchy, and let me download it. So this is the one. Okay, so titles should be very catchy. So like we have generative artificial intelligence, one of the very popular title, and here like it was published in August 2024. So now it's October 2025, right? August, September, October. So 1 year, 3-4 months only. Now, if you want like any of the like literature review, then you need to start with the abstract keyword. Keywords should also be very common and catchy, and then here introduction part in the systematic literature review. If you are focusing on systematic literature review, then for the introduction part you need to write the time period, for what time period you have taken the papers, right? So in this paper we tried to cover almost all like generative adversarial network techniques that was like proposed till 2024, right? So till 2023, 2024, because we communicated this at the end of 2023, so till 2023, and other older techniques also we covered. Then keywords like whatever keywords we use for searching the paper, those keywords were mentioned, and databases. So we try to include many as possible databases related to generative AI in this one, and like what was the inclusion criteria and what are the exclusion criteria, with all these things we mentioned, evaluation criteria. Then we are following this, so it's a summary, and then we started with a simple topic like what is generative adversarial network. Simple, basic one. What is generative adversarial network? Then different basics of like different block diagrams. Like here also we can see. So this is the basic block diagram of generative adversarial network. We try to draw it ourselves, right? Other existing diagrams are also available, but we try to modify those diagrams and we plot it ourselves by ourselves. And then different types of variants, or like different variants of generative adversarial network we discussed. Like so, the different basic variants of generative adversarial network we discussed, right? And all diagrams were drawn by us for this basic one. Already like diagrams are available because these are not our proposed work, but we modified their diagram. And then we discussed, then we have given the overview of these things also, like transformer and variational autoencoder diffusion model. So we have given the overview of these things. Then the evaluation of generative AI model means how generative AI started from earlier things, right? So earlier variants we discussed, like earlier GAN variants, and like this, all these things like supervised infogain and all those things we discussed. Then advanced in generative. So here we discussed the earlier version, basic versions. Now, along with the basic version, we discussed the advanced version also. So advancement in generative AI and their diverse applications. So for example, here in different application areas, how we are using generative AI. So generative AI for image translation, right? So here, not only like short introduction of image translation, we have written everything in detail, like overview, what are the databases and evaluation metrics for image translation. Then for medical application purpose, right? How we can use this one. So we have taken these results from some paper, right? This reference on this paper. So we discuss like how people are using generative AI. Unpaired image translation purpose, we use this one. It's a different way, like male to female, female to male, and then SAR image translation. So for like different application areas we discussed, and then variational auto encoder image translation, then like molecule generation. Now generative AI for video synthesis. So that was for the different purpose. For image, now this for video. So we did we created a separate section for that one, right? So here also like depth aware cam, talking head video generation, right? Audio driven talk head generation. So we I think already, although we copied like this these results from somewhere, right? From this because this is review and video classification with multiplication. So video related things we discuss. Then results were presented by looking some papers and all. And then here are like different other additional applications, generative AI for natural language processing. Okay, so different application areas we discuss, bird and its applications, ELMO its applications. These are all other different types of generative AI techniques, ELMO, bird. So here we are, if you are talking for ELMO bird, that means we are talking for NLP task, just like ChatGPT. So different all these things like application in malware classification, text summarization. So we try to cover like many different applications. We can't cover all applications, right? A huge number of applications, but we try to cover many applications so to make this work effective. Generative AI for knowledge graph generations or all results like we have taken results. We created this table that was like a very good generative AI application in natural language processing. What are the major good papers, very popular paper in NLP related to generative AI? So this table was created, and 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 interdisciplinary application of generative AI, right? So different graphs and all other things we have taken care. Challenge and opportunity of generative AI, challenge age and all those things, opportunities, right? So this all thing of future direction. Also, we have given some ideas also like in future how we can use, and these ideas were given in these ideas were given in different applications like multimodal generation for ethical AI development purpose. We can okay, so this is the like way we worked on and conclusion, funding, and all this. We got funding for this work, right? So we were the one partial funding we used for this one, and under their references. So many references were used here, around 150. Okay, more than 150. So around 178 references were used here.
Hello,
Okay, so
sir.
this is the way
Sir,
like.
sir, will you kindly say me the difference between generative AI and normal AI, sir? What is generative AI?
Madam, generative AI means we are like artificially generating the content, just like a chat GPT. So using chat GPT, what we are doing, we are like generating the text information, whatever question will give, and the text will be generated. Normal AI means, for example, we are doing image classification, video object detection. Image classification means everything is already available, data set is already available. Then we are classifying that, like for example, dog and cat classification. We already have cat and dog images. Then just we are classifying them. That's called AI, artificial intelligence. And generative AI means the contents are not available, but we are generating them. For example, deep fakes. I think you are aware about that. It means fake images and fake video we can generate. So this is generative AI. We are generating from existing text, and we are generating the text or image or audio, video, whatever. But those text, image, audio, video are not available. So they're called generative AI. So in generative AI, we have different applications of generative AI. Like we can apply on image, we can apply on video, we can apply on text. So if you are applying on text data set, then like we talk about the Chat GPT, large language models, and the ELMO, all these models. And if you talk about the video, then image or video, then we talk about different generative adversarial network, and vision transformers. These are the techniques for that purpose. Autoencoder. So to answer your question, generative AI for generating a text or image or video, for generating the data set, and AI is just for classification, clustering, and for object detection, object recognition, like video surveillance. What we are doing, we are detecting object. For example, if there's a terrorist and suspicious person is there, that might be terrorist. So our CCTV camera will detect that person. This is called AI. This is called AI because we are not generating anything new here. Generating means we are generating the thing. I hope I answered. Yeah. So this was the work like we did, and it was quite popular. I hope like you understood like why it was popular, because we try to incorporate so many things in the same work, and so people like it. And now, um, so now in literature review, we need to identify contradiction or gaps in finding. Now the outcome is what should be the outcome of literature review? Like we should get proper theoretical background of the particular area, summary of existing solution, and justification of new research. So you at this moment you should be able to justify like why we are going to do this new research, right, based on your existing literature. So example, the same we already discussed, like review 100 plus papers to map recent developments in machine learning for climate modeling. This is the way. And next is formulation of hypothesis. Formulation of hypothesis means to propose an assumption or statement that can be tested through scientific investigation. So, like verbally we are talking something, then people will not believe, right? So, but if you are proving that particular thing with the help of some experimentation and all those things, then people start like believing on that particular part. So, characteristics of good hypothesis are like it should be like whatever hypothesis you select, it should be clear and specific, testable, and based on existing knowledge or theory. So here, like mostly we will talk about the types of hypothesis. One is the null hypothesis and alternative hypothesis. If you talk about null hypothesis, then no relationship between variables, means whatever two variables we are comparing, no relationship between them. So null hypothesis. Alternative hypothesis means a relationship exists. So in this way, we try to do this hypothesis testing. And the example is using AI-based decision support tools in hospitals reduces patient readmission rates by 15%. Means if we are developing an AI-based DS as decision support system or decision support tool, then 15% of patients can take help from that tool. Right. So this is like how we can prove that with a hypothesis. We need to apply this null hypothesis and alternative hypothesis, and on the basis of that, we can prove that 15% we can reduce the rate. So that's a thing in formulation hypothesis. And we can use like AI assistant AI tools can suggest possible variables, relationship, and expected outcomes based on the previous data set. So we can develop AI tool here for formulating the hypothesis. Next is research design and methodology development. So for let's say for research design and methodology development is like a core point. It depends, right? Sometimes we collect the data before research design and methodology, and sometimes we collect data after research design and methodology. So it depends on your application, right? So here I'm going to discuss research design and methodology first, then data collection later on. But data collection can be before research design and methodology also. Depends on your application. So the purpose of research design methodology is to establish the blueprint of a study, what will be done, how and what do we need to use. So we need to do the study of all these things after literature review and hypothesis. So key components we are here for research design purpose. We can use qualitative, quantitative, and mixed method. Means what kinds of methods we use. Qualitative means visualized way. Quantitative means numerical way, like in the form of table and other thing, numerical format. And mixed method, like mix of both of these. So for research design methodology development purpose, we can use sampling methods like random, stratified, and purposive. I will discuss about this sampling in upcoming slide. Then data collection tools we can use like survey, experiments, observation, and different databases. Data analysis plan, like we can use statistical method. So I hope you understand the survey, experiment, observation databases. I'm not going in the detail. Survey means like we are asking people to like fill up our questionnaires, then they fill up, and then we do research on the basis of that. Experiment means we are performing different experimentation, observation, and like that. Now, next is data analysis plan. Here we do this like depend on application, but sometimes we need to do statistical methods. Means like we need to apply mean, mode, median, or like different statistical other methods and probabilistic methods are there. We need to apply. Then AI and ML models and simulations we need to do. Simulation means just mimicking the system to behave mimic the system to work like a human being, right? So that we are making a system that will work like a human being. That's like simulation kinds of thing. Means in real world we are not doing things, we are doing the things using machine, we are performing the things using machine. So AI involvement here, how we can use AI for this research design purpose? We can use AI for designing simulations. We can use AI for power analysis of sample size estimation. Here, power analysis means what sample size we require, for performing the activities, right? So that can be done. That process is called power analysis. Power analysis for sample size estimation. So that power analysis can be done with the help of AI. Means like AI can tell, like for example, you need to do research on particular university. So in the university, select 200 students. To randomly select 200 students, right? So that's a power. And AI can tell, like, just select 200 students, and they can work for this. They can like all 200 students are sufficient for this particular study. Now, next is data collection automation. Means like we are doing sensor network, web scraping. So automatically with the help of AI, we can do all these things. Example here for research design using drone and computer vision algorithms for wildlife population survey instead of manually counting. For example, we want to count number of wild animals in a forest, right? So if we manually count, then first of all that counting will not be like proper, right? Counting will not be like, it will be approximate only, because one by one we need to count, and we don't know like if like for example we counted one loin, and the same loin is coming after 1 hour from at different place, we are getting the same loin, right? So we can't count these like animal accurately. It's very difficult. And the second thing is, if you are counting manually, then it's a risk, right? These are the wild animals, so there's a risk. We should not count them manually. So better to use like a drone and like computer vision algorithms. Using drone computer vision algorithm, we can count them manually, right? We can count them like automatically with the help of our algorithm, computer vision algorithms. So here I discuss about the random, stratified, and purposive sampling. So I'm going to discuss these three techniques in detail here. So random sampling means like we have a probability sampling here. So random means random.
Sir, excuse me,
You
sir.
understand the English.
Sir, in that you said that the line while counting manually, the line is being if the same line comes, we are again counting. But how it is possible for this computer vision algorithms to detect that one, sir? If the same line is coming, how it will eliminate? How it has to do that? How it is possible for that to do this?
Very
Either the
good
drones or
question.
the this
Yeah.
one.
Yeah. Very good question, madam. And when we design computer vision algorithm, then they have a capability of recognizing any object. They can recognize, they can differentiate one object to another object. In some cases, they are powerful than like human being. Means they can recognize the small component, a small part of any of the object. That means they can differentiate one object from the another object. So, for example, our drone is flying over the forest, then then if like they counted the particular line, and that same line is coming again in that drone region after 30 minutes or like 1 hour, then our computer vision algorithm will identify we have already taken that line into consideration. We don't want to increase the count for this line. So they will identify they are like, we will make a program, computer vision program. If particular animal is already counted, then the same animal will not be counted, because they can recognize, they can identify the object. They like they can see the little bit small information also. It makes sense, because computer vision is very popular and very powerful. Means they can identify the object. Means, for example, this is the line 1, and that same line 1 comes again in the region, then they can identify it was the line 1. We already have counted that particular line, so we will not increase the same line in this area. It makes sense. But for human being, like sometimes like they can count manually, like this is the one line, another line, another line. But sometimes like the lines are same, right? One line and another line. First of all, like human being will be afraid, right? And they are like if the same line, then don't know like how they will like differentiate, right? The same line, then they will see, okay, this is one line, then the same line is coming again, then there's another line. It makes sense, madam?
Yes, sir.
So these computer vision algorithms are very popular. They can recognize the object, they can identify the object very clearly. So if one object is already counted, then they will not count that object again. Right? So this is the way. So now, if we talk about the random sampling means randomly we are selecting the elements. Means every member of population has an equal chance of being selected. So let's see how it works. Then assign number of every unit in the population, means how many like elements we need to select from the population that we can assign. So use a random number generator like different softwares, R, SPSS, Excel, to pick a sample. Even with Python also we can do that. So advantage is reduces bias, and results are more likely to be generalizable to the population. So here, like randomly we are selecting. For example, there's a winning, like there's a lucky draw. So people can complain, like if the person will not be selected randomly, then people can complain like there's a bias. So if we are selecting the winner from that lottery one, then we are reducing the bias, and results are more likely to be generalizable to the entire population. So we can give the satisfactory response to the population, like we did these things randomly, right? So this is the way like we can work on. And for example, if you want to study stress level in the university students, then you randomly select 200 students from the entire university database, right? So just for example, in university there are 5,000 students. So out of 5,000 or whatever, just select 200 students for your study randomly. Means we are giving equal chance to everyone. So randomly we selected the student. So this is called random sampling. Here most of the things are just like completely random. We are not specifying any of the criteria. Next is stratified sampling. Stratified sampling means population is divided into subgroups based on shared characteristics, right? For example, we want to do research on the basis of age, gender, education level, and samples are drawn from each subgroup. So now we first of all we divided divided complete population into groups like age group, education level group. Now from those particular groups, we are selecting the data randomly, right? So random sampling we are applying in that in those particular groups. So this is called stratified. Means here on the basis of some criteria we are going to take out the samples. So how it works? Identify important characteristics. First of all, like for example, on the basis of age, we are dividing the 18 to 25, 26 to 35 age. Divide the population into these strata, means these components, and perform random within each strata, right? Random sampling we need to perform for each strata. Now, advantage, make certain representation of all key subgroups, because if we are applying random sampling, then we don't know we got like every kinds of information or not, every kind of data or not. But using the stratified sampling, we can get the particular specific domain, key domain, subdomains we'll get. Like we have data from particular age, we have data from particular gender, we have data from particular educational level. So we will be certain about this thing. So it can improve our research productivity and research outcome. So increase precision when subgroup differences matter. So here, like, increase accuracy when, like, in our research, like, the difference between subgroups matter, right? So example is in a study of consumer behavior, you make sure that male and female response are proportionally represented according to their percentage in the population. So in a particular behavior, like, we would like to do research on the male, how many male and female people response are proportional. So based on the male and female, like, we are doing research. So if it will be good to divide into the subgroups of male and female. If you're not dividing, like, we are just randomly selected and all male came or all female came, then there's a problem. So in these cases, it is good to apply the stratified sampling. Now, next, sampling is purposive sampling. Here we do non-probability sampling. Earlier, two sampling procedure was the probabilistic one. Here it is not probabilistic one; it's a non-probabilistic one. So how to do that? Samples are intentionally selected based on the researcher's judgment or who will provide the most relevant or rich information. For example, we want to work on AI. We are working on some AI related research. And in this case, like, let's say, like, we select a random person from any of the city, then our research will not be like purposive. Like, the purpose of our research will not be fulfilled, because we are doing research on AI. So we need researchers. We need samples. Those are aware about AI things. There are so many non-technical persons. They don't know anything about AI. And if you are selecting them, then the purpose of research will not be fulfilled. So we need to go for purposive sampling. Purpose means for a specific purpose. Like, we need to select samples for our specific purpose on the basis of criteria of, like, what are our objectives. According to those objectives, we need to select the samples. So how it works? Researchers select participants who meet specific criteria, and it is non-randomization. Selection is purposeful. So advantage: use of qualitative or exploratory research, allow focus on specific knowledgeable participant. Now, if researching expert view on AI ethics, you would deliberately choose leading AI researcher or policymaker rather than sampling the general public. I hope it is clear. For example, we are doing research on AI ethics, then we should select the person who are, like, expert in AI, or like they are policymaker or something. Now, next is data collection and method. So this was the research design and methodology. After that, we are collecting that. We will discuss the data collection method. So there are different ways by which we can collect the data. So the data collection process means to gather valid, reliable data and drive meaningful pattern or conclusion. So data collection methods we are talking about, that we have the first type of data collection method is primary data. Primary data means we are collecting data ourselves. How we can collect the data? The data can be collected using experiments, survey, direct measurement, like that. Correct? Then next is second data, like open data, like open source data set is there. Just download and work on that. Government report, published data. These all are the secondary data. Analysis techniques we can use: descriptive statistics like mean, median, standard deviation. We can use some inferential statistic, regression, ANOVA, t-test. And we can apply machine learning and AI models also, like predictive modeling, clustering, and neural networks. So using these techniques, we can analyze the data. Means how the data set is working, and it's like we can how we can use this data for the particular purpose. And I'm not going in the deep of all these techniques, right? Machine learning and AI models, right? Otherwise, it will be a completely different angle. Then we can use them for pattern recognition, big data analysis. For all those purposes, we can do this data collection. I hope it is clear to everyone, right? So, for example, collecting this 500,000 tweets on mental health and analyzing sentiment using NLP models. So, we can do the sentiment analysis with the help of natural language processing. Now, next is interpretation and conclusion. So once we did all these things, then we can need to interpret and we need to conclude our outcome. So to make sense of the result and assess whether they support the hypothesis, key considerations are like, do results answer the research questions? Means whatever results we generated, they answered our research question. Are finding statistically significant and meaningful? Comparison with previous study, do results align or contradict? Or explaining unexpected results, alternative interpretation, possible errors, right? So all these things are the part of this interpretation conclusion. And examples are AI model for predicting disease risk work well on training data, but poor on the real world data. Interpretation of model limitations. For example, any of the model, for example, disease prediction model, it works very well on training data, but does not work well on real world data or test data set. Then we need to interpret that model. We need to identify the cause, where is the problem, and using that problem, we need to find the proper solution. That's called interpolation, interpolating the model. Right. So AI tools like explainable AI for model interpretation, automated report generation, all these things we can use for this purpose. Now, next is once we concluded interpreted our work, then report writing and dissemination, right? So this is an important point because we did lots of hard work in our research. Then our hard work should be known to public or researchers and other persons. So for that purpose, how to disseminate our information, how to write a report. To share research findings with the broader community through publication, presentation, patents, and the component of report writings are abstract, introduction, methods, results, and discussion. And here we can use the graphs, tables, figures generated by data visualization tool. So these are the points like abstract, introduction, methods, results, and discussion. These are the important points, and those should be included in any of the research work, in any of the research paper. Then how we can make our research effective? We can use graphs, tables, figures generated by data visualization tool like that. You can use tools like Python, R, Tableau. So here the dissemination platform where we can publish. So for example, we are publishing in general, then IEEE, Elsevier, and Springer. You're publishing in conference, then if you're publishing conference, then try to select top tier conferences like ICML, Neuro IPS, then this short form neural IPS, image processing system, information processing system, and domain specific symposium. Repository we can use archive, ResearchGate. So repository here means before publishing your work, what you can do before publishing your work, you can do the preprint. You can publish the preprint version, so other persons will not copy your work. So that archive is one of the preprint platform where you can upload your work. ResearchGate you can upload on ResearchGate also, but I don't think it will be ethical. Means unpublished work you should not upload on ResearchGate. Then social media, blogs, and YouTube for public outreach. So all these things you can do, you can follow for your for disseminating your research work or research outcome. So how AI can use here? AI can be used for grammar correction, for grammarly rightful. You can use for AI correction. For text generation purpose, you can use ChatGPT, but be very careful while using ChatGPT because we don't get very accurate result like sometimes we don't get very accurate results using GPT. So like we need to be very careful about these things. And if you are using GPT, then clearly you need to specify we use chat GPT for this purpose, right? We can make task easy with the help of GPT. We can take an idea and all those things, but we will not recommend you to use GPT for writing a paper, right? So you should be very careful about it. And there are lots of GPT detection softwares are also available. So easily your like paper can, like that text of paper can be identified without GPT. Plagiarism checking purpose, you can use AI. You can use for auto formatting to general style guidelines for guide purpose, right? So for all those purpose, you can use AI just to make your task easy. It does not mean like you will use AI for solving your problem, for writing the complete paper. No, you should be very careful about all these things, right? So a researcher uses AI to draft a proposal. For example, like a researcher is using AI to draft a proposal for Horizon Europe grant with automated compilation check. Means this is one of the very popular grant in Europe, and for that purpose, like we can use AI to draft a proposal. Here we are writing draft a proposal. We are not asking, telling like we are going to write the final proposal with the help of AI. This we are drafting proposal, but this is for taking the idea. But later on, you need to modify your proposal yourself, and you need to use your brain for that proposal generation purpose. So I will give you quick definition of AI, like what is AI. So if you talk about the artificial intelligence means simulating human-like thinking, learning, and reasoning by machine. Means if machine work like a human being, if a machine work like a human being, then we can say like this is like artificial intelligence. Means like using artificial intelligence, machine work like a human being. This is the correct way of explaining. So there are so many applications where like we are applying this artificial intelligence and machine learning techniques. For example, like in housing price prediction, we can apply simple example housing price prediction. So on the basis of previous data set, previous information, we can predict the house price of new house, right? We can predict the cost of new house, right? So on the basis of previous data set, we can train the model, and once the model has been trained, we can predict the cost for new house. So here, like in place of human being, like machine is predicting the housing cost. Okay, so simulating human-like thinking, learning, and reasoning by machine. What are the core features of AI? Means learning, adaptation, and automation. Means it learns from previous data set, it adapt that thing, and it do the automation. Means automatically it it converts in that particular format. So here if you are very new in AI, there was one previous question also, what is the difference between AI and generative AI? So AI part, I would like to give you one real life example to understand the AI here. For example, there are small the kids in their house, right? In every house, like your brother, sister, small brother, sister, your daughter, son, whatever. Let's say the age of that particular kid is 6 months, 7 months, or 8 months old. If that kid is 6, 7, 8 months old, then that kid does not know anything. That kid does not know anything. Does not know anything means that kid can touch the fire, that kid can fall from bed, or that kid can do. Hello. So that kid can do many other like relevant activities. If that kid can do many other irrelevant activities, then what the like you as elders will tell to that kid, you should not touch the fire, right? Otherwise it will hurt you. You should not go beyond uh, of this point from the bed, otherwise you will fall down, it will hurt you. So likewise you will tell, but kid will repeat the same thing again and again, around 6 times, 8 times, 10 times, 15 times. Depends on the capability of kid. Depends on the understanding level of kid. Then after some time, kid will also realize themselves. Oh, I should not touch the fire. I should not touch this fire, otherwise it will hurt me. I should not go beyond this point on the bed, otherwise I will fall down. So kid will also learn themselves, and here parents are also teaching them. Elders are also teaching them. So this is called learning phase. Learning phase, right? So first point is learning. Now, once the kid is adapting all these things, means they are knowing the things, they are kid is adapting, means I should not touch the fire, I should not fall, go beyond this point. This is called adaptation. Second point. Next is, once the kid is age of like year 5 years, 4 years, then we can say the kid is trained at that moment. Trained at that moment means, like, we can say the kid will not fall from the bed at that time. Kid will not touch the fire. Even like kid got training on one kind of fire, but even that, like, kid will not touch another kind of fire. Like kid got training for the fire from like lighter, from candles, right? Even after that, when kid is 4 years or 5 years old, kid will not touch the fire from gas stove. Or for example, like there's a fire in somebody's house, then kid will not touch that fire, right? So this is called automated automation. Means automatically kid will understand the things, like I should not touch the fire. I got training. I'm trained for this. Then I should not touch the fire, right? So this is the AI. Means automatically machine is taking decision. So here, kid is machine. Kid is model. Kid is machine learning model. So in the beginning, kid does not know anything. Kid is dumb, we can say. So in the beginning, machine learning model is also dumb, right? They don't know anything. But slowly, slowly, that model needs to be trained, right? That model needs to get knowledge, understanding, intelligence. So that knowledge, understanding, intelligence is called training part, right? Training things. So once the model or kid gets sufficient knowledge, understanding, intelligence, then we can say model is trained. Whether machine learning model is trained or the kid is trained, right? So in this way, like the AI work, once the model has been trained, then it can predict the output of unknown input, right? It can predict the output of unknown input, right? Unknown input here means in terms of kids, we can understand. For example, like after 4 years, we are sending that kid to our relative's house and our neighbor's house, right? Then in relative's house, neighbor's house, there are different kinds of fire, different kinds of like heights and all those things. Then also, like, kid can like in that case also, like, kid can perform better. Like kid will not touch the fire in our neighbor's house, kid will not fall from the bed, right? So these are testing phase. We can like test this kid. So these all things are like automatically, like all these things comes, and these are the like part of the automation. So here the definition of artificial intelligence means the model, the machine learn from experience, and they improve their performance from their using that experience. And after improve their performance, they can predict the output for unknown input also, right? The input that is not known to the particular machine, the machine can predict the output for that unknown input also, right? So this is the way, like, this AI work. And we can use AI in modern research in many of the application areas are there. Few are mentioned here. So like managing big data means we can analyze millions of patient records with the help of AI. We can predict modeling. We can predicting like customer churn in telephone. Churn means like in telephone company, like people buy a SIM, right? Buy any telecommunication service, and they left it because there are lots of offers are there. So if any company, like for example Geo SIM, SIM of Geo came, right? So many people left their Airtel and all those things. They adopted Geo, right? So this is called churn. Means how long the customer will be with us, right? Because so company do all these survey and all these like research. How long this kinds of customer will be with us. That research can be done with the help of predictive modeling. Automatic tedious task purpose, AI can automate repetitive time-consuming tasks such as data cleaning, sorting, discovery hidden patterns, means like market basket analysis in retail. So like retail stores are there. So we can identify the type of customers, like this type of customer will buy this kinds of product and all those things, right? So market basket analysis. So there are so many other fields out there where we can use this AI thing. So example here, AI in COVID-19 drug discovery, deep minds alpha fold for protein folding prediction purpose. We can use this one. Okay. So this is the way like we can use AI, and AI importance in multidisciplinary disciplines. So many disciplines are there, like medical imaging, weather forecasting, or sentiment analysis for social media, right? So why multidisciplinary research needs AI? Complex real-world problems span multiple domains. AI integrate knowledge across fields. Like with different fields, also we can combine, and AI can work on those. So example like healthcare plus AI means cancer diagnosis from medical image, environmental science plus AI, so predicting climate change patterns, social science plus AI, social media sentiment analysis. Here we can incorporate AI with different fields. Like we can incorporate with, we can combine with healthcare, we can combine with environmental science, we can combine with social science. So many in different application areas we can use this AI. So I'm not going in the deep of these like AI subfields. Okay, let me discuss this one. So there are like different types of approaches, like machine learning techniques, right? So earlier, like machine learning came, then nowadays like deep learning is quite popular. So there are three types of like machine learning techniques: supervised, unsupervised, and reinforcement learning technique. If you're talking about supervised learning techniques, then there are two types of supervised learning techniques. One is the classification, and another is the like regression. So if you're talking for classification technique, that means they're classifying the data set into the different, right? So classifying data set into different categories means like we are doing the dog to cat classification. Simple example, right? We are classifying whether it's a dog and whether it's a cat. So based on their features, we can classify them. And the other applications of like classification maybe in diagnostic, customer retention. Customer retention means whether the customer will be with us for a long time or not. Image classification, identity fraud detection, like for those purpose, we can use classification. Next is regression techniques. So regression we can use for like advertising, poultry prediction, weather forecasting, market forecasting, and all those purpose we can use this regression part, right? So here like this is a machine learning, a supervised learning algorithm. In supervised learning algorithm means like we have a labeled data set. We have input, we have output. Label is there. Next part of machine learning is unsupervised learning techniques. In unsupervised learning techniques, like we have clustering and dimension reduction. That means we are dividing our data set into groups based on their particular characteristics of the data set. And dimension reduction means we are reducing the dimension. For example, we have 150 features. We don't want 150 features. Like we want only 50 features. So we can reduce the dimension of the data set. So different application areas are mentioned in front of you. Same way we have reinforcement learning technique, means we are learning from experience, we are learning from penalty and reward. That will be like reinforcement learning techniques. So these are the three main techniques, three main parts of that machine learning. So I'm not going in the deep of this computer vision things, right? I'm going to skip this because like it will take time. Now, here, if you talk about the research areas, so let's just quick give you a quick overview of areas related to like computer vision. So computer vision, there are so many areas, but like few are mentioned here. Computer vision we can use in healthcare, multidimensional data analysis, and disease prediction. We can use it for object detection, tracking and recognition, visual surveillance, monitoring, driver assistant, defense system. And another one like we can use for dimension reduction, right? If there's a very high dimension data set, then we don't require dimension. So dimension reduction here means like, for example, we are working on any data set, and let's say we want to like do research on any particular students. Like we want to do research on particular class, right? in university, there's a particular group or particular class, and in that class we want to do research on those students, like what kinds of students they are. So we are collecting the features of the students. So we want to study their performance, right? Class performance. So if we are collecting the features from students, then we ask the features from the student. Then students give features like how much marks they got in their previous class, and how much active they are, how many assignments they solve, how many hours they study, right? And all these like relevant features we collect. But along with that, what is their date of birth and all those. And along with that, student also gives some features. Let's say where is the native place of those students, and like what their fathers do, and what their mothers do, and like so many other like different types of questions like we get from like students, right? How many hours they play and all. So these, like, let's say 150, total 150 features we collected from students. What is their blood group? What is their phone number? Like that. Okay. So out of these features, if you want to do a study for class performance, then we can understand many of these features are not important, right? Many of the features are not related to our study, although they are important for their students, or like although they are important for a particular student, but they are not important for our study. So what we can do, we can reduce those features, we can reduce the dimension. So out of 150 features, for example, we are interested only in 50 high confidence features, then with the help of dimension reduction we can reduce those features, right? So this reduction can be done with the help of different algorithms like principal component analysis. Autoencoder can also be used for dimension reduction, right? So we can use them. So this is the purpose of dimension reduction. High dimension data visualization. Nowadays, like we have very like a large amount of data set we have, and the data sets are represented in like in depth also, right? So high dimension data set is also there. So how to visualize the data set? So the visualization is a very complex part of that high dimension data. So we can do this with the help of some like our approaches, right? Computer vision algorithms. We can do for image enhancement purpose. Right? Then next, make yourself so next, like we can use this for medical imaging purpose, like for like BMI segmentation, cardiovascular, like disease detection purpose, brain tumors, right? Right. So now after machine learning, there's an era of deep learning where like supervised popular, and deep learning is we have a two layers, we have high number of layers. So due to high number of layers, we can extract, or we can identify the which information, better information than the machine learning. Although the deep learning is also part of this. And if you want to apply deep learning model, then you should have large data set, right? You don't have large data set, right? So why these all are popular? People GPU and all, right? Nowadays we have the GPU, to process the data, and we have different libraries out there, PyTorch, and so due to all these libraries, availability of these libraries, and like most of them are free. So that's the reason like deep learning is quite popular, and they are performing very good also. These are things like so I'm going to skip this these things. So there are different AI subfields are there, like related to like different subfields of AI are there related to NLP. So if we talk about the related to NLP, natural language processing. So if we talk about the natural language processing task, then we can use this NLP for information extraction. For example, we have given 2000 words of text, and from this 2000 words of text, we want to extract only like 3 or 4 questions, right? 3 or 4 statement is useful for everyone. Then you can use AI again. And translation purpose, you can translate language speech to text, you already know, right? Like for example, in YouTube, you will speak like hello, hello Google, or hello, can you play this song for me? Like speech to text. So your YouTube software will convert that speech to text, then they will play, and they will search that particular song for you. Same with text to speech, semantic semantic equivalence, entailment. Entailment means meaningful information you can extract. Conference resolution, OCR, question answering, right? And text summarization, you can summarize the text. Sentiment analysis means you can identify whether this product will be popular or not, or you can identify whether people like this particular product. That was saying you can identify which is the positive sentiment, negative, right? So here, like you can use this. These are the like different fields, different subfields related to AI, and all these related to NLP. All these are very popular now. Lots of research is going on for these fields. Now, AI tools we can use for ideation purpose also. Like this, we can use like AI for different idea generation purpose, right? So generative AI applications. So although I don't use these tools just for like knowledge, but I still here. So, but we can take advantage of these tools, like for text purpose, like Jasper and Omni and tools are there. For video purpose, we have like Wiki and robots. For image purpose, we have tools, right? For coding purpose, we have tools, right? So we have tools. That's good. We can use these tools for like to make our task. Now, how we can use AI for drafting messages for outlines, right? So here I'm not telling like we should use AI, like I mentioned before here, but why we should not take advantage of this? Why should we not take like help of AI they can support us and they can increase our code, right? But we should not over depend, we can say, on AI. We should use our mind also. If you will not use our mind, then your mind will not work after some time. Few like weeks before, there was our post on social media, like one from university. They did research on people like who use AI or who don't use AI. There was clear difference between the mind of both persons, right? So you should be very careful. So you can use AI for idea generation for a small purpose, but you should not use AI for completing a task, completing an assignment. So you also know. So AI tool like ChatGPT, Notion AI, Jasper AI can generate skeleton functions based on forms. Examples like draft a proposal outline for AI-based healthcare monitoring system. AI can output structures such as title, introduction, problem statement, or objective, all those things. They can give you some outlines, but you need to complete that part because you should not just direct copy because if you are using AI, then it will save time and make sure about the complete The important point is transparency. If you are using AI drafting and clearly you need to tell, clearly state AI tools for used in drafting. Human expert must validate all AI generated text, accuracy, relevance, and depth. It is always not possible like AI will generate accurate, right? Sometimes AI can also do it, right? Once you use ChatGPT on the bottom, you will see the text AI can do the mistake. So you 2-3 minutes. And using AI, then you need to mention in your research paper or in any article, like you use AI. Otherwise, that will not be feasible. So AI can support researcher in early phases of writing proposals, like drafting section. AI can generate or define key proposals, like background, production purpose, methodology purpose, expected impact purpose, possible society. Means with the help of AI, you can identify whether our work will be impactful in the future or not. So AI can help by giving ideas of measurement section. For example, I suggest using a random forest method with Metropolitan to analyze the times measure. Like sometimes people are confused which machine learning model to apply. Just you can ask, they can suggest like this is your data set at this time, like apply this kind of thing. So they can give you a range of ideas, right? Then language enhancement, like we are like non-English speaking, we are non-English speaking country, right? So sometimes our language might not be good, right, in majority of cases. So we can enhance, we can improve our language with the help of different AI like grammar, right? Tools that we can use. Like we can make our writing professional, right? And you know, like the presentation and the writing of proposal, each like the way of writing the proposal is an important point when we publish it, right? If your paper is not written in proper way, then it's very difficult. So using useful AI tools for proposal writing. For example, you are using write tool. This is one of the primary function. Academic language enhancement purpose, you can use write. So you can check vocabulary, tracing image to publish academic literature to make sure scientific form. We can use Grammarly. We can use ChatGPT, right? So like there are different purpose, like different tools have a different purpose. Like Grammarly for grammar, spelling, clarity check. ChatGPT for drafting outline, brainstorming. So AI, for example, we are searching any draft, we are making any draft using AI, and that draft is AI in smart graphic manner. We ask AI just like propose a draft in a smart graphic manner. So what AI will do? So here on the right hand side, these are the AI generated, right? The so propose section, introduction. So here you can see, like you can find some AI related text. Now, once we are generating the AI related text, then you will see mostly like you will see that AI generate the text in general. For example, we are writing AI in smart graphic manner. We want specific things, but like mostly AI will give you answer in general. So you can take help from them, but specific content you need to generate. So here is an example. You can see the text. These are the text generated from the AI and how like this text like there and how you can improve them. So after generating from AI also you need to generate. You need to improve. So draft outline can be defined by the function specificity and now next is like advantage and challenges of AI research. Like advantage are time consuming. AI can accelerate the process of drafting outline, section and reduce manual. Means your process will be how quickly you can do it. Idea expansion, AI can suggest novel angles, perspective that culture might provide. Yes, you can expand the idea. For example, you are struggling in generating the idea or other things, right? So and our idea is not that powerful. We can take about improve structure. AI makes sure logically consistent with the flow by providing structure template. Challenges, risk of superficial content. AI generated text may sound correct but lack depth, originality, and numerous differences. Always require human input. Ethical concern purpose, like this AI related risk, like plagiarism risk. AI may be the same in article. In AI generated text, prevent plagiarism. Authorship ambiguity purpose, bias, insights, right? Need for human expertise. final content must always be reviewed, validated, and supplemented by project matter experts to safeguard scientific integrity and quality. Right? So these are the things we need to take care, and like there are advantages also and challenges also. So we need to be very careful about the things. We are using AI, we are using GPT and other things. We need to take care about the ethical consideration, ethical things, and how ethically we can use this. So the same thing like I'm writing on the downside of this slide, like the same thing I explained. So like guidelines, how ethically we can use AI, like what it's clearly stated what usual drafting. Critical review, human expert must validate all generated sections for accuracy, nuance, and depth. Plagiarism check means use plagiarism detection tools to ensure originality, complement and non-replace. AI should assist in process, not fully replace judgment and right. So we should use our knowledge, we should use our cognitive ability. If you will not use our cognitive ability for a long time, then you will lose that. Right? So just keep your mind about otherwise is lots of problems with time remembering the things. And so to conclude all these things, AI tools can help researchers draft and improve research proposals faster and better. They assist with creating outlines, writing sections, improving language. Using AI saves time, brings new ideas, but should never replace judgment. Okay, third point is very important. Ethical use means checking AI out carefully and avoid editing. Human review is essential to ensure quality or quality accuracy. AI is an assistant when used responsibly. Right? So responsibly. Okay, so that's all from my side. Thank you. If you have any question, any point you would like to discuss, then I'm ready for the discussion. That's all from my side. And I can see that so many people are here. So if you are interested in artificial intelligence, computer generated research, either student or professor, then they can send me email or they can contact me by the media. So media platform, I will be happy to discuss like proposals and about. So thank you very much. Any question?
So, what is entailment regarding NLP?
Entailment. So entailment means, madam, we are extracting the useful information from that NLP part. Means, like for example, useful information. For example, we are getting the meaningful information. For example, we have given 200 or 500 words of text to that particular GPT, and from that text we are asking the answer from that particular part, like whether in this text we can we can give the answer of this particular question or not. Like we have given the text for any movie, like 500 word of text we have given. Now we are asking from the text, what is the summary of this movie and what is available, who is the actor in that movie. If the name of actor is mentioned, who are the actor in that movie. So the entailment means useful information we are going to extract from that particular part. So that will be the entailment thing.
Thank you, sir.
Any other question, please?
So all these AI tools are paid versions only, no, sir? No, any free versions are there? which will help us.
Many are free. ChatGPT 3.5 is free. So people are using this also AI, and many different libraries, AI library we use. So these are the mix, right? Few are free, few are like mix out of the deep six you can use, and you can use this ChatGPT and all those things, right? This is free, but many are paid. If you are going for higher version of GPT 4.0, 4.0, GPT 5, then you need to pay. But many are free also. Okay, so I think there is no question. Let me see in chat box. No. Okay, so either you can contact me this my official email ID, Sanjay sir. Thank you very much for sharing this one, and or you can contact with my personal mail ID. I can give you.
Thank you, Sandeep, for your nice session.
Thank you, sir. Okay, so I can stop it now. Thank you very much. Bye.
Thank you very much for your time.